Welcome everybody. Today we will see the numerical example for decision trees. Let us see the example of bank loan sanctioning. Loan seekers' income and credit score are given as input. Approval of the loan is the output of decision tree classification, whereas the amount of loan to be sanctioned is the output of decision tree prediction. Previous loan data is the given input. Income in thousands of rupees of the loan seeker is shown in the first column. Second column shows the credit score. Third column shows the actual loan amount sanctioned in thousands of rupees. Fourth column shows whether the loan is sanctioned or not. Entire data set is considered at the root node and the best attribute is chosen for the split. First, let us choose income as the attribute for splitting the data. The total number of elements at the root node is the number of loan seekers, that is 4. Let the number of subsets be 2. As there are 2 subsets, it is a binary split. As income is the attribute chosen for the split, the loan sanction data is arranged in ascending order of the income. For n elements, there are n-1 possible values of binary split. We will be starting with single element in one group and n-1 in the other. Next split will have 2 elements in group 1 and n-2 in the group 2. This will continue till number of elements in group 1 becomes n-1. As there are 4 elements in loan sanction data, 3 splits are possible. The group wise elements in each split is given by 1, 3, 2, 2 and 3, 1. In the first split, 30 is in group 1 and 60, 80, 100 are in group 2. In the second split, 30, 60 are in group 1 and 80, 100 are in group 2. In the last one, 30, 60, 80 are in group 1 and 100 is in group 2. Let us assume the first split with group 1 element as 30 and group 2 elements 60, 80 and 100. Total number of elements T presented to the root node is 4, out of which S1 takes 30 and the rest are assigned to S2. Number of elements NE in S1 is 1 and in S2 is 3. By referring the loan sanction data, loan sanctioned in S1 is nil and not sanctioned is 1. So number of S is 0, that is Y is 0 in S1. Probability of split is given by NE divided by T, which is 1 by 4, that is 0.25. The probability of S is Y by NE, which is 0. Probability of no is N by NE, which is 1. Gini impurity is 1 minus square of probability of Y minus square of probability of N. When Gini impurity G is multiplied by the probability of split P, we get the Gini measure. In similar way, values of S2 are calculated. By referring the loan sanction data, loan sanctioned in S2 is 2 and not sanctioned is 1. So Y is 2 and N is 1 in S2. Probability of split is 3 by 4, that is 0.75. Probability of S is Y by NE, which is 0.67, and probability of no, which is N by NE, is 0.33. Gini impurity value is calculated as 0.44. Gini measure for this group is 0.33. Gini index is the sum of all Gini measures, that is 0.33. Gini index is used for selecting the best attribute for the split. Table shows the calculation of Gini index for all the 3 splits. Out of these, Gini index of 0.33 is the best. Let us choose the credit score as the attribute for splitting the data. The total number of elements, that is number of loan seekers, is 4. Again, the number of subsets is 2. As credit score is chosen as the attribute, the second column in loan sanction data is arranged in ascending order. As there are 4 elements in loan sanction data, 3 splits are possible. The group wise elements in each split is given by 1, 3, 2, 2 and 3, 3. In first split, 300 is in group 1 and 500, 600, 700 are in group 2. In the second split, 300, 500 are in group 1 and 600, 700 are in group 2. In the last one, 300, 500, 600 are in group 1 and 700 is in group 2. Gini index of credit score is calculated for all the three splits as in the case of attribute income. Gini index of first and third split are 0.33 and that of second split is 0.5. Let us recall the Gini index value of income attribute for first and third split are 0.33 and for the second split is 0.5. As Gini index 0.33 is the least value, we can choose any one split with Gini index 0.33 as the best attribute value for the split. We have chosen first split in the income attribute as the best value for the split. Group 1 has one element 30 and group 2 has three elements 60, 80 and 100. Split point is the average of last element in the first group and the first element in the second group. Creation of decision tree node containing the selected attribute and the split of data set into subset is shown in the figure. At the root node, the decision to be made is whether the income is greater than or equal to 45. Accordingly, it is split into subsets. Loan application is rejected for all the elements in the first subset. Hence, it is a leaf node. Whereas, second subset is an internal node since for two elements, loan sanction is approved and for one, it is rejected. Further split is possible only at the internal node. Hence, the three elements in the subset 2 are considered for next split. Subset 2 data is arranged in ascending order of credit score. As there are three elements, two splits are possible. The group-wise element in each split is given by 1, 2 and 2, 1. In first split, 300 is in group 1 and 500, 700 are in group 2. In the second split, 300, 500 are in group 1 and 700 is in group 2. Credit score is chosen as the attribute for splitting data. The total number of elements, that is number of loan seekers, is 3. The number of subsets is 2. Gini index of credit score is calculated for both the splits. Gini index of first split is 0 and that of second split is 0.33. As Gini index 0 is the least value, we can choose this as the best attribute value for the split. The best attribute chosen for split is shown in the table. Group 1 has one element 300 and group 2 has two elements 500 and 700. Split point is the average of last element in the first group and the first element in the second group. It is 400. The growth of the decision tree is shown in figure. At the parent node, the decision to be made is whether the credit score is greater than or equal to 400. Accordingly, it is split into subsets. Loan application is rejected for all the elements in the first subset. Hence, it is a leaf node. In second subset, loan sanction is approved for all the elements. So, it is also a leaf node. As all the nodes are leaf nodes, further classification is not possible. So, tree growth ends here. The decision tree grown with the given data is shown in figure. Leaving out the data values, decision tree for classification and prediction is shown here. Let us take three different loan seekers data. One with low income and low credit score 3400, one with high income and good credit score 7700, third one with high income and low credit score 8350. Let us first take loan seekers data 3400. At the first decision point, his income is lower than 45,000. The tree follows the red path and he is not sanctioned any loan. Let the loan seekers data be 7700. At the first decision point, his income is greater than 45,000. The tree follows the red path and reaches the internal node. At this internal node, his credit score is checked. As his credit score is higher than 400, the tree follows the red path and reaches the leaf node. His loan is sanctioned. Let the next input be 8350. At the first decision point, his income is greater than 45,000. The tree follows the red path and reaches the internal node. At this internal node, his credit score is checked. As his credit score is lower than 400, the tree follows the red path and reaches the leaf node. His loan is rejected. Table shows the classification and prediction for 3 different loan seekers using decision tree. For one with low income and low credit score, that is 3400, and one with high income and low credit score, 8350, loan is rejected and their loan sanction amount is 0. For the one with high income and good credit score, 7700, loan is sanctioned. The predicted loan value is the average of loan values of elements at the leaf node. By referring the loan sanction data, it is the average of 100 and 200, that is 150,000. In this video, we have seen how decision tree is grown for the loan sanction data and how the tree grown makes the classification and prediction for new loan seeker. Thank you. Thank you for your patient listening.